let's look at practicing with intersections. So again, a typical problem whenever you're looking at intersection would be something like, A is from 1, 2, 3, 4, 5, and then to say, well, B is 4, 5, 6, 7, 8. If you wanted to know where A was intersecting with B, then that's literally like, which guys do they have in common? So if this person says, I can only eat at 1, 2, 3, 4, 5, and this person says, I can only eat at 4, 5, 6, 7, and 8, the only time, or only places, whatever, that you can take them both out to eat are at 4 and 5. That's the only time that they're going to be happy. So the intersection of those two would be 4 and 5. Okay? So you're going to see problems like this kind of perk up here and there, but where it gets a little bit more interesting, I think, is messing around with greater than and less than kind of things. So if you're going to have an intersection problem, it might look something like this. X is greater than or equal to negative 2, and X is less than or equal to 5. Let's just make it less than 5. Less than 5. So this could be written as an intersection, or to say and. You could say and. So we're going to say X is greater than or equal to negative 2. I'm going to draw it out in the number line, and then I'm going to write X is less than 5, and draw that out on the number line. Draw that out on the number line. There we go. So I'm going to line up the numbers. So for the first one, X is greater than or equal to negative 2. So I'm going to fill in the circle and go to the right. Now some books are doing this new thing where they do a bracket and off to the right. It's fine, whatever floats their boat. Now X is less than 5, open circle, off to the left. And again, your books might be doing open parenthesis, and then going off to the left. If we want to talk about writing these in interval notation, this goes from negative 2 all the way up to infinity. This second one goes from negative infinity all the way up to 5, but does not actually include 5, so we'll write that as a parenthesis. Now, if I want to say that X is greater than or equal to negative 2, and X is less than 5, that means I have to be able to satisfy both of their conditions. So I want to think about where they intersect. And means intersect. I have to have this, and I have to have this, and I have to have this. The only way I can meet these is to find where these intersect. So I'm looking from left to right. They don't both intersect here. See, there's one has it, but the other one doesn't. One has it, but the other one doesn't, until I get to negative 2. At negative 2, they both have it. I don't know why I wrote 5. But at negative 2, they both have it. So it gets filled in. All right. Then, as I continue to go, they both have it, 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 up until 5. Now, at 5, he doesn't have it anymore. The top guy does, but the bottom guy doesn't, and the pickiest person wins. So he refuses to eat at 5, so we can't eat at 5. But we can eat anywhere from negative 2, which I guess would be 10 o'clock, to 5. And any time in between, as long as we don't eat at 5. Because this guy says, I won't eat at 5. And kind of thing. So if I wanted to write this in interval notation, I would say that the answer is going from negative 2, including negative 2, all the way up to 5, but not actually including 5. So let's try another one. So let's say we had something like this. Say we had X plus 5 is greater than 6. And 3x minus 7 is less than or equal to 14. So I recommend pausing the video, go try to work this out, see if you get an answer, and if you do, great. If not, come back and see where you may have made a mistake. So I'm going to see what I can do about this. So first thing I need to do is I need to isolate the x's. So I have x is greater than negative 1, and let's see, plus 7. So 3x is less than or equal to 21. Divide both sides by 3. X is less than or equal to 7. So I have x is greater than negative 1 and x is less than or equal to 7. except I can't subtract. That's a positive 1. There we go. Thought that sounded weird. Okay, so on the top guy, positive 1. The top guy, he's greater than 1. So open circle and off to the right, or open parenthesis and off to the right. Less than or equal to 7, close circle and off to the left, or bracket and off to the left. And I can say that x is greater than 1 and x is less than or equal to 7 is going to be where these intersect. So again, thinking about taking people out to dinner. If this guy refuses to eat here, then this has to be open. The top guy refuses to eat at 1 o'clock, but will eat anytime after. So he won't eat at 1, but he'll eat anytime after. The second guy will only eat until 7, and never after that, but he will eat at 7. So anywhere between 1 and 7, we can go to dinner. So our interval notation here will be from, right negative, from 1, not inclusive, that's why it's a parenthesis, all the way up to 7 with a bracket on it. Now you can have someone that's so picky, I'm sure you know, you can have someone that's so picky that you simply cannot meet all the requirements. So a great example would be to say x is greater than or equal to 2 and x is less than or equal to negative 3. So you might immediately say, well, how can I be greater than 2 and less than negative 3 at the same time? The answer is, well, you can't. So let's just show you, though, what this is going to look like. And this is why you really can't solve these problems, I don't think, without actually coloring them in, because it's just real easy to miss something like this because you're in a hurry and you're just working the problems and you're like, woohoo, I'm getting them done. And then you get half of them wrong. You're like, what did I do wrong? This doesn't make any sense. So x is greater than or equal to 2. X is less than or equal to 3. And if I try to say x is greater than or equal to 2 and less than or equal to negative 3 at the same time, you can see that there's absolutely no place that these guys intersect. See? They don't intersect, they don't intersect, they don't intersect, don't intersect. I don't really know what I'm drawing here, but, you know, they're not intersecting at all. There's just nothing that I can do that's going to keep both these guys happy at the same time. So actually what you want to say here is if there's no solution, sometimes we'll see it drawn like this, like an empty set. And that's another option as well. Now, one way that you might end up seeing these problems is something along this line. You might see something that looks like this. Say 3 is less than 5 minus x is less than, say, 9. Now this is this is an intersection problem. It's literally saying that this is less than this and this is less than this. 3 is less than 5 minus x and 5 minus x is less than 9. So there are some teachers that'll say to do it this way. Let me show it to you both ways, actually. I'm going to go ahead and separate it out, and I'm going to solve each one separately. It's going to look a little weird, though, but we're just going to do it. So I want to get my x over to the left, because it just looks weird right there. So I have x plus 3 is less than 5. Subtract 3 from both sides. No, not that. Subtract 3 from both sides. So x is less than 2. Subtract 5 from both sides. So minus x is less than 4. But then I'm going to have to multiply both sides by a negative 1. And hopefully you remember that if you multiply or divide both sides by a negative, you have to flip the direction of the sign. So less than becomes greater than. So I have x is greater than negative 4. Okay. So I can go and I can write this out. X is less than 2. Oh, it's going to be negative 4. X is less than 2. X is greater than negative 4. Less than 2. Greater than negative 4. And we'll end up with x is less than 2 and x is greater than negative 4. So where do these guys intersect? They intersect from here to here, from there to there, and that should pretty much take care of it. So they're going from, ooh, not bracket, from -4 to +2, but not including the endpoints. Okay. So there's one way to do it. Let me rewrite it, and I'll show you another way that you might see these done sometimes. And these sometimes make sense to me, but they sometimes don't. But you'll see people work these like in line. So the idea would be, if I do anything to one side, I have to do it to all 3 sides. I don't know if I should even bother saying this, just be confusing. So if I want to subtract 5 out of the middle, I got to subtract 5 off of each side on the end. So I end up with something like this. And then I want to multiply it by a -1, and then I got to multiply this by a -1, and then I got to multiply this by a -1. And since I'm multiplying by a negative, I got to switch the signs. And then it's just weird, because it's out of order. So I kind of got to read it backwards and say this. So if that was confusing to you, it totally makes sense why. Not makes sense and you're strange, but literally makes sense why that's confusing. But these people would read it that x is between -4 and +2. So you're kind of getting the same answer. So if you drew this out, it'd be between -4 and 2. So you're going to get the same answer. Just to me, this seems like magic. It's not really magic, I mean, clearly, or else you wouldn't get the right answer, but it just seems kind of like, ta-da, here's the answer. I'm like, no, that doesn't make any sense. But just kind of wanted to let y'all know that that's another way that you can write these. But I tend to want to just break them up into 2 and solve them like normal. Now, we could rewrite some of our previous answers. So like this one here, we could rewrite and say that x is between -2 and 5. It can actually be equal to the -2. So we can say x is between -2 and 5. That's another way to say that. This one here, we could say x is between 1 and 7, but it can actually be equal to the 7. That's another way to note that. Obviously, there's still no solution there. So this is just another notation they might ask you for. The thing to remember about this is if you think about the greater than signs as being as like little alligators because it eats a bigger number or whatever, the alligators are always going to the right. They're always going this way. Chomp, chomp, chomp. So you're always going to have them open up this way. But then you could say it's between 1 and 7, but it can actually be equal to the 7. So that's one more notation that you might actually see related to this kind of work.